In the previous video, we examined average velocity under situations of constant acceleration and found that the average velocity was halfway between the beginning velocity and the ending velocity. And we also saw that that velocity occurs at exactly 1.5 seconds in this example, or halfway through the time interval. That's only under conditions of constant acceleration. And to illustrate that, I want to make up a second example. And this one, where the acceleration will be one value for a while and then another value for another period of time. So let's say, to begin with, the acceleration is 0 meters per second. And then a little bit later on, it switches to acceleration of 2 meters per second. Okay, so at time 0, they're going 0 meters per second. And then at time 1, well, they've changed their velocity by 0 meters per second, so they're still going 0 meters per second. And then 0, and let's say 0. And now at 4 seconds, let's say that the acceleration switches, and now from 3 to 4 they speed up at a rate of 2 meters per second every second. So now they're going 2 meters per second, and then 4 meters per second, and then 6 meters per second. Now, if we look at that particular situation, then in this case, if we look at these velocities, we end up with average velocity of 0, plus 0, plus 0, plus 0, plus 2, plus 4, plus 6. And all over 7. And that's going to come up with an average velocity of 1.7-ish meters per second. So not at all the 3 meters per second that we found before. Now, it may appear as though if we just took the endpoint velocities that we would again get 3, but the problem is that that step isn't legitimate because the acceleration isn't constant. And so we need to add up the velocities at every instant in time. In fact, technically we should be adding them up even in the tenths and the hundredths between these seconds. But you can see just from looking at the individual second intervals that the average velocity of 1.7 meters per second is not what we'd expect to be consistent with a constant acceleration. Here the acceleration is one value, here it's another value. It's not constant. Now, that process would hold true during that interval and that interval. Let's take a quick look at that. So in this interval, the average velocity during that green interval is going to be 0 plus 0 plus 0 plus 0. 4 is 0 meters per second. And that velocity will occur at that average velocity will occur at all times because the velocity is not changing. Now, on the other hand, if we look at this next interval, we can again, here the acceleration is again constant in that interval, and we can again use the technique of adding up the endpoint velocities and dividing by how many there are, which is 2. And so this is going to be an average velocity of 8 over 2, or 4 meters per second. That average velocity occurs at exactly halfway through the interval from 4 to 6 seconds, or that occurs at 5 seconds. And of course you can see that it does. Those are some features of the average velocity under situations of constant acceleration. Now here's one for you. Let's say that our average velocity is 20 meters per second, and let's say that the object ends up going ends up going 30 meters per second. What